Okay, so good day. And for today, we'll be discussing the solution, okay, on your first quiz. So for the following topics, so for the antiderivatives, integrals leading to logarithmic, as well as for exponential functions. So your first part of your quiz, so it's true or false. So let's try to answer the following. So the first one is the integral of the sum of two functions is the same or is the sum of the integral of each function. So if I'm going to translate this one into a mathematical representation, the integral of the sum of two functions. So we have the integral, and the sum of two functions. The first function is f of x, the second is g of x. And then it mentioned here that it will be equal to the sum of the integral of its function. So that would be the integral of f of x dx, then plus the integral of g of x dx. And this is actually the sum and difference rule, okay, of integration. So therefore, this statement is true. The second statement, the integral of a constant with respect to x is equal to the constant multiplied by x. Okay, so let's say we have a constant k, so with respect to x. So its integral, of course, we can move out k. So using the coefficient rule, then dx, and then k, the integral of dx is x, plus of course the constant c. So therefore, this is true that the integral of the constant with respect to x is the constant itself multiplied by x. So that makes the statement true as well. The third one, so the power rule of x raised to n dx equals to x raised to n plus 1 over n plus 1 plus c, so which is used in finding the integral of an algebraic function, is applicable so for all positive and negative integer values of n. So as we have seen on the definition of the power rule, there is one exemption. And that exemption is when n is equals to -1. Okay, so n should not be equal to -1. Otherwise, the result would be a logarithmic function. So therefore, the statement is actually false. Next, the integral of the quotient of two functions is the quotient of the integral of its function. Okay, so the integral of the quotient of two functions. So the quotient of the functions would be, let's say, the integral of f of x over g of x, then dx. So it's equal to the quotient of the integral of its function. So that would be f of x, so its integral, divided with the integral of g of x dx. So which is not true. Okay, so that makes the statement false as well. The quotient of the integral of its function. Next is the constant of integration is added on every antiderivative to represent all the variables that become zero after differentiating a function. So let's say we are to find the derivative of x squared plus 2, so which is 2x. And then the derivative of x squared plus 1/4, that would still be 2x. However, once we integrate 2x dx, so this is the same as 2 times x squared all over 2 plus c. So that makes it x squared plus c. So we're in c here, so represents the 2 and 1/4 that becomes 0 after differentiation. So therefore, making the statement to be true. The next one, the integral of the product of two functions is the product of the integral of its function. So let's say the integral of f of x multiplied with g of x, then dx, will it still be the product of the integral of its function multiplied with the g of x dx? Again, so there's no rule for quotient and product. So therefore, this make the statement false. Okay. So that makes it false. Okay, so it's because there's no such rule. Okay, so for the product and the quotient, it's only the sum and difference rule in integration. So let's proceed with the following questions. So this time around, I'll be because when I look at your solutions, okay, so for on your quiz, many are still at a loss on what to do. So therefore, I'll be solving this one in two ways. Okay? And then just try to select which one would be better for you. So I'll be using substitution approach first. And then afterwards, I'll be using the direct approach. Okay? So we use neutralizing factor right away. Okay? But again, for this one, so find the derivative of 2x plus 5 multiplied with x squared plus 5x raised to 7 dx. Looking at the given integrand, so it would suggest that it would be the same, or we could use the power rule here, because if our u will become x squared plus 5, 7, it's most likely that we'll be able to get the 2x plus 5. So I'm going to arrange, okay? So this one would be the format, u raised to n du. Okay? So as to use the rule x raised to n plus 1 all over n plus 1 plus c. So u raised to n, so our u would be x squared plus 5x, and then raised to 7, and multiplied with our du, so which would be 2x plus 5 dx. Okay, so by substitution approach, I'm going to let u so to be x squared plus 5x. And then our du then, so will be derivative of x squared, it's 2x. Derivative of 5x, that would be plus 5. And multiply it, of course, with dx. So by substitution, so I could substitute that this x squared, okay, plus 7, so that is u, then raise it to 7. And then this 2x plus 5 dx, it's the same as this, so that makes it equal to du. So thus, I can now use the formula, u raised to n, wherein n is equals to 7, so that would make it u raised to 8 all over 8, then plus c. And I have to transform it back to u, wherein u is x squared plus 5x, and multiply it with 8 all over 8 plus c. So which resembles this answer. So that is by substitution approach. Although there's no difference. So by direct method, so for the direct method, it's the same thing. So our u is x squared plus 5x raised to 7 raised to n. And then multiply it with our derivative du, so which is 2x plus 5 dx. Okay, so which is exactly as the original integrand. And thus, there's no need for neutralizing factor. So right away, we can use the formula x raised to, or sorry, this should be u raised to n plus 1. So that would be our u, it's x squared plus 5x raised to 7 plus 1, which is 8 all over 8 plus c. So which is just the same. Okay. The solution is just direct. Okay. So that is for question number 1. So for question number 2, so most likely, so there's no need for substitution here. So this is a direct approach or direct use of the power rule. And as I mentioned before, so when we integrate radicals, so we transform it into a rational exponent. So the square root of x would be 1/2, then plus 1 over x raised to 1/2. However, so to use the power rule, it should be at the numerator. So we need to change the exponent into a -1. So that would be x raised to -1/2 dx. So that would be the transformation of the original integrand. Okay, so the square root of x is x raised to 1/2, and then 1 over the square root of x is the same as 1 over x raised to 1/2. However, I want to transform it to the numerator, transfer it to the numerator, so it will become x raised to -1/2. And then we apply the power rule. Okay, so again, the power rule, that would be x raised to n dx, so would be equal to, or that would be equal to x raised to n plus 1 over n plus 1 plus c. So that is our formula. And then the shortcut that we are using before, that is x. So to get plus 1, that would be 1 plus 2, it's 3 all over 2, and divide it with 3 all over 2. And plus x raised to -1 plus 2, it's 1 over 2, 1/2 over 1/2. And then we'll have plus c. However, so since this is a multiple choice, we have to resemble the given choices. So the reciprocal of 1 or 3 over 2, so that would become 2/3, x raised to 3 over 2, then plus 2, x raised to 1/2, then plus c. 2/3, okay, they are not the same. So let's try to make this one in radical form. So that would be 2/3, and then the square root of x cubed, then plus 2 the square root of x, then plus c. However, the x cubed, so it can be factored out as x squared times x plus 2 the square root of x plus c. And then x squared is a perfect square. So it has a square root, so which is x. And then will remain the square root of x, then plus 2 the square root of x plus c. So which is the same as the first choice. So that would be the integral. So 2/3 of x times the square root of x plus 2 the square root of x plus c. Okay, so that's for question number 2. For question number 3, so this one, I'm assuming that the u here is 1 plus x squared. So once I derive that one, I'll get a 4x cubed. Okay, so therefore, so most probably the formula that we will be using there, so would be the integral of u raised to n du, or u raised to n plus 1 over n plus 1 plus c. So therefore, I need to follow this format. Okay, so the format then will be u. So most probably the u here will be the 1 plus x raised to 4. 1 plus x raised to 4. However, so we need to transfer it at the numerator. So that would make it -1/3. Sorry, it should be -1/3. And then our assumed du then, that would be the remaining part, so which is the x cubed dx. Okay, so let's now have our u. So our u here is 1 plus x to the 4th. Then our du is, so derivative of 1 is 0. So x to the 4th is 4x cubed dx. So let's try to do it by substitution. So by substitution, that will be the integral of 1 plus x to the 4th is u, and raised to -1/3. And then our x cubed dx, so this is x cubed dx in excess of 4. Okay, so In that case, it should become du all over 4. Okay? Because x cubed dx, it's just du all over 4. I'll have du over 4 here. So moving that out, so I'll have 1/4, the integral of u raised to negative 1/3 du. And 1/4, that would be the integral of, multiplied by u raised to negative 1/3 plus 1, negative 1 plus 3, it's 2 over 3. And we'll have 2/3 as well there. Let's see. Then afterwards, the reciprocal of 2/3 is 3 all over 2. So 3 over 2 times 1/4, that will be 3 all over 8 u raised to 2/3 plus c. Or in short, that would be 3 all over 8. U then is 1 plus x to the 4th raised to 2/3. Okay, so 2/3 plus c. So 3 over 8, 1 plus x to the 4th, 2/3 raised to 2/3 plus c. Okay, so which is the first choice? But again, if I'm going to do this one by direct method, so I could use this format. So the integral of u raised to n. So u is 1 plus x to the 4th. Then our n is negative 1/3. And then what is our du? So du is this one. So multiply it with 4x cubed dx. So comparing this one, so with the original, okay, so we are in excess of 4. So that's why we multiply it with 1/4. And afterwards, so we can now use our formula. So that is 1/4, multiply it with u raised to n plus 1. So our u is 1 plus x to the 4th. Negative 1/3, so plus 1 would be 2/3 all over 2/3 plus c. Or that would be 3 over 2 times 1/4 is 3 all over 8. So multiply it with 1 plus x to the 4th raised to 2/3 plus c. So either of the two, so we have the same answer. So again, so it's up to you. So which one you understand better. So if you understand the substitution better, then follow that solution. Okay? It will just take you time. Okay? It has a longer solution as compared to direct method. Number 4. So in number 4, as you can see here, it is something that is complex. Okay, it's a ratio. So definitely we cannot use the logarithm here. It's because the degree of the numerator is higher as compared to the degree of the denominator. So in this case, the best thing to do is perform some operations here or factor out something if there's something that is factorable. In this case, I think there is something that is factorable. So for the numerator, so we have x squared minus 5x, so x is common. So x squared divided with x, that will be x, and then negative 5x divided with x would be negative 5. So similarly, so 3x plus 6 is factorable. So something that is common there is 3. So 3x divides 3, it's x. Then 6 divides 3, it's 2. So x plus 2. Then divide it with, so x squared is factorable as well. So x and x. So the factor of 10, it's 5 and 2. I'll have a negative 5 and a positive 2 there because this one would be negative 5x and the outer would be positive 2x. So negative 5x and positive 2x, we have 3x. So which is this one, negative 3x. So that would be the factor. So this would be product. So therefore, x minus 5 and x minus 5 is common. X plus 2 and x plus 2 is common as well. So leaving us only to have the integral of 3x dx. So which is simply, so 3x squared all over 2 plus c, or 3 over 2 x squared plus c. So question number 4 is very direct. Okay, so you just need to factor it out, and then afterwards it would just be a power rule. So let's have example number 5. So question number 5. So find the integral of the square root of x to the 4th plus 2x squared dx. In this case, the first approach here is to transform this one into a rational exponent. So that will be x raised to 1/4 plus 2x squared, and then raise it to 1/2 dx. So usually, if we have such form, so we use power rule. However, if I'm going to use the power rule, so it would suggest here, okay, that our u would be the x to the 4th plus 2x squared. But once we derive that one, so that will become 4x cubed plus 4x, wherein we cannot get the dx there. Okay? The dx is very simple. So in short, I could not, or we cannot use the power form right away. Okay? So because once we derive u, we're not be able to get the rest of the integrand. Okay? So it's not enough. The rest of the integrand is not enough. So with the derivative of our u. But as you can see here, the term or the function inside, okay, is factorable. So wherein x to the 4th and 2x squared, its factor would be x squared. So x to the 4th divided with x squared, so that is x squared. Then plus, so 2x squared, and then divided with x squared, so we just have 2, then raised to 1/2 dx. And afterwards, so we have product, okay, of x squared and x squared plus 2. And then both are raised to 1/2. So remember, if we have a times b, then raise it to n. So this is the same as a raised to n, b raised to n. And this is what we will be doing here. So we'll have x squared, raise it to 1/2, which is our a raised to n. Then the other one is x squared plus 2 raised to 1/2. Then multiply it with dx. Then x squared raised to 1/2, that is 2 times 1/2, that is just x. Then I'll have x squared plus 2 raised to 1/2 dx. So our u then, so we can now use the power rule. Our u would be x squared plus x. Then our du then, so will be 2x. So x squared plus 2 would have 2x dx. So by substitution, so that will be our u. Okay, so this is our u. Integral of u raised to 1/2. 2x dx. Okay, what only have is only x dx. So this x dx in excess of 2, so I'll have du all over 2. Or that would just be 1/2 the integral of u raised to 1/2 du. So therefore, this would be 1/2 the integral of u raised to 1/2, that is u raised to 1/2 plus 1, 1 plus 2 is 3, all over 2, all over 3, all over 2, plus c. And so which make it to be equal to the 1 over 3 over 2, it's 2/3. So 2/3 times 1/2, that is 1/3. So just have 1/3 u raised to 3 all over 2 plus c, or just simply 1/3. So u is x squared plus 2 raised to 3 over 2 plus c. So which is the same as our first choice. That is by substitution approach. But if we're going to do it by direct method, so this one is the same as the integral of u, which is x squared plus 2 raised to 1/2, and then its derivative, it's 2x dx. So it's 2x dx here. And it's not the same as this one. So I'm going to multiply it by 1/2. So giving us 1/2, Then x squared plus 2, 1/2 plus 1, that would be 1 plus 2, it's 3 all over 2, all over 3 all over 2 plus c. And then 1/2 times 1 over 3 over 2, actually cancel itong 2 na to, would just be 1/3 x squared plus 2 raised to 3 all over 2 plus c. So we have the same answer. X squared plus 2 raised to 3 all over 2 plus c. Okay, so let's have the last question for the first part. Okay, so first part of your quiz. Find the derivative of x plus 3, x minus 1 squared dx. So in cases like this, so whenever you are seeing an exponent which is greater than 1, so most of the time you are tempted to use the power rule, so right away, or the chain rule, so right away. However, the thing here is, if we're going to use the power rule, our u here is x minus 1, so which is this. However, once we derive it, that is just dx. How about dx plus 3? Okay, so we cannot use the power rule unless once we derive it. Okay, so once we derive u, we'll get the rest. Okay, so we'll get the rest of the integrand. If we cannot get the rest of the integrand, then that formula is not applicable for that integrand. So in this case, the chain rule, okay, so using the power rule, cannot be used right away. Because once we derive x minus 1, so we cannot get the x plus 3 there. Okay, so in those cases, this is what I keep on telling you. So whenever there's an operation involved, then try to perform the operation first. Okay? So in this case, it's just x minus 1 raised to 2. So therefore, it will be easy to expand. Okay? So we'll just have x plus 3, then multiply it with x minus 1 squared. So by binomial expansion, so square the first term, so we have x squared, and then twice the product of the first and the second term. So 2 times x times negative 1 will have negative 2x, and then negative 1 squared, that would be plus 1 dx. And afterwards, so I'll multiply. So I'll distribute the first term to the trinomial. So x, multiply it with x squared, will have x cubed. Then x, multiply it with negative 2x, I'll have negative 2x squared. Then x, multiply it with positive 1, will have plus x. So x cubed minus 2x squared plus x. And then the second one, I'll start with the 3. So multiply it with x squared, so plus 3x squared. So 3, multiply it with negative 2x, so negative 6x. And 3 times 1 will be positive 3 dx. Have, okay, so 3x squared minus 6x plus 3. Then we combine similar terms. So x cubed, so only 1. Then we have negative 2x squared and positive 3x squared. So I'll have positive x squared. Then x minus 6x, I'll have minus 5x. And then plus 3 dx. The integral of this then, so we can just use the power rule. So that would be x, so 3 plus 1 is 4 all over 4. And plus x, 2 plus 1 is 3 all over 3. And minus 5, 1 plus 1 is 2 all over 2. And plus 3x plus c. Okay, so this is a trick question. So there are choices involved. So you might be tempted to use this one, x to the 4th. This is x cubed. But the problem with that choice, okay, so with this choice is the absence of 5. So there's no 5 there, but there is 5 at the numerator. Then we'll have the 3x plus c. So in those cases, okay, so don't treat this one as it would appear that there is just an error on the choices. It's not. Okay, so probably you need to still do something. So once you have your board exam, so there might be choices like these. Okay, so we're in. You already got the correct answer. However, you cannot find the answer to the choices. Okay, so you have to take a look at the choices. It might be equal. So in this case, it should be equal to the first choice. But what happens to the first choice? It combines. Okay, so it combines all the numerical coefficient of the term. So in this case, the LCD here is 12, right? So 12 divides 4, that is 3. So I'll have 3x raised to the 4th. So 12 divides 3 is 4, so plus 4x cubed. And 12 divided 2 is 6 times negative 5. I'll have negative 30x squared. Then 12 divides 1, it's 12 times 3, that would be plus 36 plus c. So rearranging that, so I'll have 1 over 12, so 3x to the 4th plus 4x cubed minus 30x squared plus 36x and plus c. So which is the same as the first choice. So this one is simple. However, you have to be very careful. Okay, so in choosing the correct answer, so based on the given choices. Okay, so sometimes, okay, so the choices are tricky. Okay, so let's now proceed with the part 2. Okay, I'll be solving so set A and set C. So set A and set B are quite the same, so they just have different given. So similar with set C and set D are just the same. So therefore, I'll be solving set A and set C only. Okay, so let's start with set A. So for set A, number 1, so we have the integral of 3 plus x squared all over x dx. So in here, so definitely we cannot use the logarithm right away here. So because the degree of the numerator is 2, the denominator is 1 only. So that's an improper fraction. So we can separate. Okay, so we'll make this one 3 all over x plus x squared all over x. And multiply it with the x. And then I'll have, so 3 all over x. So x squared all over x, it's just x dx. So I could move out 3 here, and the integral of dx over x, and plus the integral of x dx. So dx over x is ln x. So 3 times ln x plus x dx, that would be x squared all over 2 plus c. So that is the first one. So that the items 1, 2 to 3 would be by 6 points. Okay, so that's as simple as that one. Okay, so for the first item, for number 2, we have the integral of 3x cubed all over x to the 4th plus 5 dx. So we can use substitution here, or we can use the direct approach. I can rewrite this one. So I'll move out 3 there. And the integral of or I'll make it the same. I'll retain it. Okay. So my attack with this one, so most probably this is logarithm. So our u here x to the 4th plus 5. So once we derive this one, we'll have 4x cubed dx. Okay, so our x cubed dx, so we'll just have du all over 4, so will be x cubed dx. So by substitution, so that would be the one below, it's u, and then we still have the 3 there. So 3, and then x to the 4th plus 5, that is u. And then this x cubed dx, that is du all over 4. So du all over 4. So moving out the constant, I'll just have 3/4 there, and du all over 4. That makes, or sorry, du over u. That makes it 3/4. Du over u is ln u plus c. Or just simply 3/4 ln our u is x to the 4th plus 5 and plus c. You want it by direct method, so I'll just have the integral of u below, okay, and then our du is 4x cubed. Oh, sorry. The one below is x to the 4th plus 5 and 1. And then our du is 4x cubed. Right? So 4x cubed dx. So we move out 3 because that is constant. And 1 over u, 1 over x to the 4th plus 5, and then its derivative is 4x cubed. So comparing it with the original integrand, so we are in excess of 4. So therefore, the answer would be 3/4 ln of x to the 4th plus 5, then plus c. So that is by direct method. So number 3. So for number 3, so we have e raised to negative 1 over x squared dx. Okay, so my assumption here, this is just an exponential function. So this is the same as e raised to negative 1 all over x, and multiply it with dx over x squared. So our assumption here is if this is an exponential function, our u is negative 1 all over x. And then, so we can rewrite that negative 1 over x, that's the same as negative x raised to negative 1. Right? So we move up the x. So it will become x raised to negative 1. So once we derive it, so du then will be negative 1 times negative would be positive. Then x, negative 1 minus 1, it's negative 2 dx. Or simply, this is dx over x squared. So by substitution approach, this would be e negative 1 over x, that is u. That is u. And then the dx over x squared, that is du. So what is eu du? It's just eu plus c. So e, our u then is negative 1 all over x plus c. So by direct method, it's direct. It's the same as the original integrand. So that is eu. Our u is negative 1 all over x. So what's the derivative? This is the du. Dx over x squared. So comparing it with the original integrand, it's exactly the same. So therefore, I can now use right away the formula. That is e negative 1 all over x plus c. Number 4. So we have 4 raised to x minus 2 raised to x, then 3 raised to x plus 5 raised to x dx. So this is a product. Okay, so product of two exponential functions. But again, so remember these. Let's say a b raised to n again. So that would be a raised to n, b raised to n. So as long as the exponent are the same, so we can combine the two. So get the product of the two bases and then raise it to the same exponent, which is n. So in this case, I'm going to use the FOIL method. So first term, 4x and 3x, so that would be 4 times 3 raised to x. Because n here is x. Okay, so we just combine. Okay, so we just combine the exponent. And then outer term, 4x and 5x. So both are positive. So positive 4 times 5 raised to x. And then the inner term, so negative 2 and 3. So we just have a negative of 2 times 3 raised to x. And then last term is 2x and 5x. So a negative of 2 times 5 raised to x as well. So everything is multiplied it with dx. So this would be the same as 4 times 3, we'll have 12x, then plus 4 times 5, it's 20x, and minus 6 raised to x, and then minus 10 raised to x dx. So finally, so we can now use our formula. So that's just 12x ln 12. So plus 20 raised to x over ln 20. And minus 6 raised to x all over ln 6. Then minus 10 raised to x all over ln 10 plus c. Number 5. So for number 5, I'll have e raised to 2x, so multiplied it with e raised to x plus 1 raised to 2x. So again, it might look again that this one will be power rule. But again, if we let u, so to be equal to e raised to x plus 1, so its derivative would be ex dx. But this is different. This is e raised to 2x. It's not e raised to x. Okay, so therefore, we cannot even make it as e raised to x times e raised to x, and then afterwards we neutralize it by e raised to x. The others, okay, so what they did is they made it, okay, so e raised to x plus 1 raised to 2, and they multiplied with e raised to x dx. Because once we derive it, we have this one, and then we have the power rule, but then we are in excess of e raised to x, so what they did is they made it this one, 1 over e raised to x. So remember, we cannot neutralize a given integrand by a variable. Okay? So there's no, the coefficient rule is only for constant. Okay, so not for variable. So therefore, we cannot use the power rule here. So what can we use then? So what we can use then is we distribute or we expand. So e raised to x squared. So e raised to x squared, it will have e raised to 2x. Then twice e raised to x times 1, that would be plus 2 e raised to x. Then 1 squared will be plus 1, then dx. And we distribute, we'll have e raised to 4x plus 2 e raised to 3x, then plus e raised to 2x dx. So in this case, so we can use Okay, so we have a u here, which is 4x. So du would be 4dx. So u here is 3x. So du would be 3dx. So u here is 2x. So du would be 2dx. So what can we see as the in excess here? It's the 4, the 3, and the 2. Okay, so we can use the substitution again, or we can use the direct approach. But our neutralizing factor for the first one is 1/4, the second is 1/3, the third one is 1/2. So I can write directly the answer here, no? So this would be 1/4 e raised to 4x. And plus we still have 2 multiplied with 1/3, so 2/3 e raised to 3x. And then plus 1/2 e raised to 2x plus c. And that is number 5. For number 6, x squared plus 7 all over x cubed plus 21x minus 5. So once this one, probably this would be a logarithm. I could let u, so to be x cubed plus 21x minus 5. So our du here would be 3x squared plus 21x is 21 and multiply it with dx. However, 3 is factorable. So this would be x squared plus 21 over 3 is 7 dx. So using the substitution method, so we just have 1 over u, so which is our u is the x cubed plus 21x minus 5. But how about this one, the x squared plus 7? So here it is, x squared plus 7 dx, but with an excess of 3. So therefore, we multiply this one by du all over 3. Or simply 1/3 the integral of du over u. And this is 1/3, so du over u is ln u plus c. Or just simply 1/3 ln of x cubed plus 21x minus 5 plus c. So by direct, so we have 1 all over x cubed plus 21x minus 5. Its derivative is 3 times x squared plus 7 dx. So comparing it with the original, we are in excess of 3, so we'll have 1/3 there. Our final answer then would be 1/3 ln of x cubed plus 21x minus 5 plus c. That is number 6. And for the last one, we have e raised to the 4x all over e raised to 2x minus 1 dx. So again, so can we use logarithm here, wherein u will be e raised to 2x minus 1. So its derivative would be 2 e raised to 2x dx. The thing here is, this is e2x, this is e4x at the numerator. So we were not able to find, or we were not able to have an equal derivative with that of the numerator of the original integrand. So therefore, we cannot use the natural logarithm here. But what can we take? Okay, so from the given. So this would be a ratio of two exponential function. So the degree or the exponent for the numerator is 4. The second is 2. So that makes it as an improper fraction. So in that case, so if it is an improper fraction, usually the thing that we were doing is we divide, okay, the numerator by the denominator. So doing that, so I'll have e raised to 2x minus 1. Kasi, sorry. So we have e raised to 4x, and then we divide it with e raised to 2x minus 1. So we divide the first term, e raised to 4x divides e raised to 2x. So that is e raised to 2x. And e raised to 2x multiplied with e raised to 2x, it's e raised to 4x. E raised to 2x multiplied with negative 1, we'll have negative e raised to 2x. Then we change the sign. So this one will become minus, this one become plus. So e raised to 4x minus e raised to 4x is 0. So then we have positive e raised to 2x. So there's nothing above. So we'll just have e raised to 2x here. So we can stop there. Although e raised to 2x still divisible by e raised to 2x, which is 1. However, doing that, kasi yung kanina, so para magkaroon tayo ng, or if to use the natural logarithm, so once we derive the denominator e raised to 2x, so we should have an e raised to 2x at the numerator. So we can only do that one if we stop here. Okay. In short, this is the same as e raised to 2x, and then plus, okay, the remainder, which is e raised to 2x, divided with the divisor, e raised to 2x minus 1. And everything is multiplied it with dx. Right? So in here, so we can have our u, so to be 2x. So its derivative then will be 2 dx. Ito naman, ang u natin is e raised to 2x minus 1 because I can get the numerator here, which is e raised to 2x, derivative of 2x, it's 2 dx. So using the direct method, so this is only by direct. You want to by substitution, you can do so as well. So by direct method, so this is the same as the integral of e raised to 2x. So its derivative, the du is this one, so which is 2 dx. So there's no 2 at the original integrand, so I'm multiplying it by 1/2. And then the next one would be plus the integral of our u, so which is 1 over e raised to 2x minus 1. And then its derivative, it's 2 e raised to 2x dx. So comparing the original, so we are in excess of 2. So I'll have 1/2 there as well. So our answer then would be 1/2. So the integral of e raised to 2x, it's just eu, so e raised to 2x. And plus 1/2, so this one would be logarithm. So 1/2, sorry. So 1/2 ln of e raised to 2x minus 1 and plus c. So that would be our answer then. 1/2 of e raised to 2x plus 1/2 ln of e raised to 2x minus 1 plus c. Okay, so that will be the solution for the set A, quiz 1. So let me answer set C. Okay, so quiz 1. But this time, I'm not going to use substitution approach anymore. Okay, again, if you want to do by substitution, excuse me, you want to do by substitution method, then do so. Okay, but it takes time. So I'm going to answer this one directly. Okay, so for the first one, we have x squared plus x plus 2 over x minus 1 dx. So looking at the first example, or first item, so the degree of numerator is 2, the denominator is 1. So therefore, that's an improper fraction. So we divide. If you can factor it out, okay, but the factor of 2 is 2 and 1 only, and we cannot get the x at the middle term. So there's no factor for x squared plus x plus 2. So what we're going to do is we divide. We divide x squared plus x plus 2, and divide it with x minus 1. X squared divides x, it's x. X times x is x squared. X times negative 1, it's negative x. And we change sign, so this is negative, this one becomes positive. So x plus x will have 2x. So 2x divides x would be positive 2. 2 times x, it's 2x. So 2 times negative 1 is negative 2. So we bring down the positive 2 there. So we change the sign. So this is negative. So this one becomes positive. And 2 plus 2 will be 4. So rewriting number 1. So that will be x plus 2. And I'll just have plus 4 all over x minus 1 dx. So ito, obvious naman. Ang u natin is x plus 1. So ang du natin will be dx. So right away, we can use the formula. No? So x would be x squared all over 2. Then 2x with a constant. And then plus 4 ln of x minus 1 and plus c. So that is item number 1. For number 2, so we have 3e2x over 2e raised to 2x minus 5 and dx. So our u here will be 2e raised to 2x minus 5. I'm assuming this is logarithm because we have the same degree for the denominator and the numerator. So du then will be, so e raised to 2x, derivative of e raised to 2x, it's 2 dx. However, 2 times 2 will become 4. Okay, so for the derivative, e raised to 2x, so derivative of 2x, it's 2 dx times 2, that would become 4. So its derivative is 4e2x dx. So using this one as logarithm, right? So I'll move out 3. Okay, then the integral of, so 1 over 2 e raised to 2x minus 5. And however, its derivative is 4 e raised to 2x dx. So 4 is in excess, so we divide it by 4 there. Okay, so as we use the logarithm, so this one will become then 3/4 ln of 2 e raised to 2x minus 5 plus c. 3/4 ln of 2 e raised to 2x minus 5 plus c. So number 3. So number 3 is the integral of ln x over x dx. This is direct. However, let me rewrite this one. Ln x, multiply it with dx over x. So I can let my u here to be ln x. Then its derivative is dx over x. Okay, I was able to get it right away. So therefore, I don't need to rewrite it. So ln x, it's u, and then dx over x is du. So therefore, I can use the power rule. That would just be ln x, raise it to 2 all over 2 plus c. Number 4, we have 2 raised to x plus 5 raised to x all over 3 raised to x dx. So again, remember our rule, if we have a all over b raised to n, that's the same as a raised to n all over b raised to n. And we can do this one here as well. So the 2x all over 3x, that is the same as 2 over 3 raised to x and plus 5 over 3 raised to x dx. So which is the same as 2 over 3 raised to x ln of 2/3 and plus 5 over 3 raised to x all over ln of 5/3 and plus c. So that is for item number 4. For number 5, so we have e raised to 2x plus 1 and e raised to 2x minus 1 dx. So there's an operation involved here. So we multiply. However, this is sum and difference. Okay, so sum and difference of 2 terms. So therefore, we can just square the first term and minus square of the second term. And this is e raised to 4x and minus 1 dx. You want to do the FOIL method, do it. So e raised to 2x will just be cancelled out. So e raised to 2x minus e raised to 2x will be 0. So our answer there would just be e raised to 4x minus 1. So again, so this is just an exponential function. Our u is 4x. Our du is 4 dx. So therefore, we have a neutralizing factor of 4. Or just simply the integral of e raised to 4x. So its derivative is 4 dx. So we're in excess of 4, so we multiply it by 4. And minus the integral of dx. So simply 1/4 e raised to 4x minus x plus c. So 1/4 e raised to 4x minus x plus c. Number 6. We have the integral of x squared minus 8 all over 2x cubed minus 48x minus 5 dx. So our u is 2x cubed minus 48x minus 5. So its du would be 6x squared minus 48 dx. However, 6 is factorable, so we'll just have x squared minus 8 dx. So this one, so this resembles a natural logarithm. I'll just have 1 all over u, so which is 2x cubed minus 48x minus 5. And our du is this one, which is 6x squared minus 8 dx. But then we are in excess of 6. I said this is x squared minus 8 dx. Ito yon. And so we multiply it by 1 over 6. So the answer then would be 1/6 ln of 2x cubed minus 48x minus 5 plus c. So that is the natural logarithm, right? So the derivative of the denominator is the same as the numerator. And lastly, we have e raised to 3x over e raised to x plus 1. This is the same as the previous, but the difference is this is 3x. Right? I'll do e raised to 3x, then e raised to x plus 1. So what I want here, so to use the natural logarithm, so I should end up with e raised to x as well. Okay, so that my remainder would be e raised to x. So e raised to 3x divides e raised to x, it's e raised to 2x. And 2x and x is e raised to 3x, and plus e raised to 2x. and we change sign. This is minus, this is minus. I'll have negative e raised to 2x. So negative e raised to 2x time divided with e raised to x would be negative e raised to x. And negative e raised to 2x, then I'll have negative e raised to x. So this one would become positive, this one will become positive. I'll just have e raised to x. I'll stop here because they have the same e raised to x. This one would be e raised to, okay, so for the quotient, e raised to 2x minus e raised to x and plus the remainder, which is e raised to x over the divisor, e raised to x plus 1 dx. And here, so we have our u, so to be 2x, so our du would be 2 dx. Other one's just direct sub. The next one we have, our u would be e raised to x plus 1. Our du would be e raised to x dx. So we rewrite. So we'll start with the first term. So e raised to 2x. So its derivative, it's 2 dx. So I'll multiply it with 1/2. And minus, so e raised to x dx. Then plus, so this one would be natural logarithm. So e raised to x plus 1. So its derivative, it's ex dx. And okay, so there's no need for neutralizing factor. So we're able to get the numerator. So the answer here now will become 1/2. So e raised to 2x. And minus e raised to x. And then plus ln of ex plus 1. Let's see. So 1/2 e raised to 2x minus ex plus ln x plus 1 plus c. And those are the solutions. Okay, so for our quiz number 1. Okay, so you may use this one as your reference in reviewing, and think you need to go back again. Okay, based from what I am seeing, you're still not comfortable on what formula to use. Okay? You always resort with the power form. Okay? So not all of the time, so we will use the power formula. Okay? So we only use the power formula once we derive u, and then we'll get the rest of the integral. If it is not, then use other formula. Probably you need to expand. Okay, so you need to perform the operations involved. You may use the exponential function formula or the logarithmic function formula. Okay, so that will be all for your quiz. Good day and God bless always.